Okay, this is your Chapter 5 and 7 May-June review on polynomial operations. It's combining both Chapters 5 and 7. Chapter 5 was adding and subtracting polynomials, and Chapter 7 was multiplying and dividing polynomials. Both require slightly different operation senses to be able to do so, but as we go through this review, you'll see that you can seamlessly go between the two. So the first question is a true-false, and it says the degree of a trinomial, and then it says 4x squared minus 2xyz plus 1 is 5. Because, well, the first term is 4x squared. It has a degree of 2. The second term is negative 2xyz, which, of course, would be an exponent of 1 on the y, the z, and the x. And plus 1 doesn't have a degree. Now, remember, degrees of any term. So if I was to make this one here, 4x cubed y, what we learned is the degree of a term is the sum of the exponents. So if you're calculating the degree of any one term, in this case this monomial, you would simply look at the exponents, and this is a 3 is an exponent, and on the 1 is an unwritten, or on the y there's an unwritten 1. So the degree of this term would be 4. If I looked at 5xyz, that's a monomial. Each of those variables has 1s on them. So the degree of this one would be 3. And the reason why we learn degree is usually when we have more than in a binomial or trinomial or polynomial, we usually order them in descending degree of terms. So the only purpose in grade 9 is to order your terms. So when we talk about what is the degree of a trinomial, the difference is the trinomial itself also has a degree. And the degree of a trinomial is simply the degree of the term that is the highest degree. This term has a degree of 2. This term has a degree of 3. And since this one doesn't have a variable nor an exponent, it has a degree of 0. So in this particular trinomial, the degree of it is actually not 5. It is a degree of 3. The whole thing has a degree of 3 because this term has its highest degree. And therefore, the answer to the first question is false. The degree is not 5. It's not the sum of all of the degrees of the terms. It's the sum of it's the degree of the term within the trinomial that determines the degree of the term, of the polynomial. I know it's a wordful, but I think you get the idea. So, question number 2 says A times B times C is a trinomial. Well, when we studied the definitions of them, if we have 3 terms that are either added, I'll put the subtraction here just to show the difference. A plus B take away C is what we call a trinomial because it is the sum of 3 different terms. But when we have A times B times C, that can be written as simply ABC because we know that when a variable or a number is next to another variable, it means multiplication. And therefore, A times B times C looks like a trinomial, but in fact, it is a monomial. Similarly, if I put 2 multiplied by y multiplied by y, this would actually be written, if I was to simplify it, as 2y squared, which is also a monomial. So the product of parts does not make a monomial, binomial, trinomial. It is the sum of or the difference of more than one term that determines whether it's a binomial, a trinomial, or a polynomial. So in this particular case, it's actually one term, the product of A, B, C, and therefore it's false. It's a monomial. Okay, but if it was, for example, A times B plus C, here would be an example of a binomial because A times B is really AB, and plus C, that would simplify down to a binomial, and therefore this one would be actually a binomial when I simplified it down to AB plus C. Question 3 says y times y is 2y, and y times y harkens back to grade 8 when I did something like 3 times 3. And we learned that 3 times 3 is multiplying itself twice, which exponentially is written as 3 squared, and in standard form would be written as 9. If it was 10 times 10, we write that as 10 squared, which is 100. If it was y multiplied by y, we would write that as y squared. And since we don't know the value of y, we cannot write it as a standard form, but we do know that exponentially it's not written as 2 times y, but rather y times itself. So therefore 3 is also false. Question 4 has to do with adding like terms. It says 4x plus x. So if I was to draw this, there's an x. There would be 2x. There would be 3x. There would be 4x. So there's 4x plus an additional x. Does that equal 4x squared? Now remember, 4x squared would look like this. It would be an x squared, right? And then I would take that. 4 of them would be infinite cloner. I would have 1, 2, 3, 4. Are these the same thing? The answer, of course, is false. No, they're not. And what is 4x plus x? Well, it's actually, if I squeeze this together, it's not 4x squared, but rather 5x, right? When you gather like terms, as long as the variable and the exponent are the same, you can keep them and add them together and simply combine coefficients to put them together. Now, conversely, let's pretend this question was something different. Let's say it was 4x squared plus x. In this particular case, I can't add them at all because they are not like terms. Yes, they share the same variables, but they don't share the same exponents. So therefore, 4x squared plus x simplified is 4x squared plus x. You cannot gather like terms. Your next question. What is a simplified expression that represents the perimeter of this triangle? I don't know. So perimeter of a triangle, of course, would be this side plus this side plus this side, because the perimeter is really the distance around the shape. So if you're, oh, sorry, wrong way. Okay, back here. So if I'm calculating the perimeter of this triangle, I really want to take a 2x plus a 2x plus 1 plus a 3x minus 1, or this side plus this side plus this side, the sum of all three sides. Again, another way to phrase this question is gather like terms, or add the polynomials together. Add the monomial to the binomial to the binomial. So here, again, if I think of it as being a drawing, I'd have 2x here. I'd have an additional 2x here, plus 1. And I'd have 3x over here, and a minus 1. So if I think about it pictorially, that's what it would be. When I gather like terms, I could gather all my x's. I have 2, 4, I have 7 x's. And when I gather this constant with this constant, these two together are going to make what we know to be a zero pair. So therefore, when I add the three sides together, the perimeter of this triangle would be the monomial 7x, right? We can declare it just to be 7x. Your next question says, what is a possible width and length for this rectangle if the area is 4x squared minus 2x? So again, the question really is, if I have what side length here plus multiplied, excuse me, by this side length would give me this. So if I think back to when we modeled it, and I put 4x squared and 4x squared, and I put a minus 2x and a minus right there. So there would be an example of my answer. My area is 4x squared minus 2x, and if I was to then figure out what this is, well, this would be 2x's, and right here would be 2x there. So I'd have 2x minus 1 up here and 2x over here, which would mean in my area, one of the possible combinations is 2x minus 1 and 2x. But that's not the only combination. I could have actually did it a different way. And I'll press pause and set it up for you. So there's another way my model could look. And up here, I would have an x. And down here, I would have an x and an x and an x and an x and a minus 1 and a minus 1. So this would be an x multiplied by a 4x minus 2. That would be another possible. So 4x minus 2 would be here, and x would be here. That's another possible width and length. And the other one we could have done as well is a little bit, I think that's the only two, isn't it? Is that the only two? No, I could have taken a 2 out as well. But for purposes of what we want, 2x minus 1 times 2x is one way, and the other one would be 4x minus 2 multiplied by x. Next question says simplify. So you're given a trinomial, and you're asked to add it to the binomial of 3x minus 2. Again, another way I could have worded that is gather like terms, if we're adding. Right, gather like terms. So when adding, you simply want to look for your x squareds, your x's, etc. So I have 4x squareds, which can't be combined with any other term. so they're kept as is. A negative 2x and a positive 3x combined. If I think about pictorially, there's negative 2x, there's a positive 3x. Those would make a 0 pair, leaving me with a positive x and a positive 2 and a negative 3. 0 pairs leave me with a negative 1. So when I gather like terms or simplify or add those two together, I would end up with a trinomial of 4x squared plus x minus 1. Here we have the addition and subtraction of a binomial, a trinomial, and a trinomial. The key here is when you're subtracting trinomials, you remember that the easiest way to do it is to change it to addition and use the inverse of each term within the polynomial, in this case a trinomial. So I'm going to actually add it to those. Once you've made that change, you're going to gather like terms, starting with your highest degree terms, in this case happens to be your x squareds. I have a positive 2x squared here and a negative 10x squared there. Those are going to combine to leave me with negative 8x squared. So my x squareds are done. I have 10x here, 3x here, that's 13x, and a negative 5x. 13x and a negative 5x will be a positive 8x. My x's are done. And then a negative 3 and a negative 1 and a positive 2 are going to make a negative 2. Now, you might have this as your answer. You might have negative 8 minus 8x squared minus 2. That might be somebody's answer as well. Oh, sorry, x squared. Those are both the same. The only difference is I rearranged my terms within my trinomial in descending degree of terms, which is easier for teachers to correct because if you descend them properly, all of your answers will look like that. And if somebody's answer was this, it's technically right, but the teacher has to actually think about, is that the right answer? So it's much easier for teachers to have you rearrange them in descending degree of terms. Your next question is simply a trinomial take away another trinomial. And just like the last question, change it to addition and use the opposite. Oh, sorry, that's not the opposite. That's the same. The opposite of each term. Now you simply gather the terms, starting with your highest degree terms first. X squared and negative 2x squared will be a negative 1x squared, or simply negative x squared. Your x squareds are done. A negative 3x and a negative 3x make a negative 6x. And your positive 1 and your negative 1 are 0 pairs, or cancel each other out, leaving you with no constant. So your final answer will be negative x squared minus 6x. Next question is the product of a monomial and a binomial. And what we learned to do was you learned to actually multiply using distributive property, just like we would do in grade 8. So the first question is, what is negative 4x multiplied by negative 2x? What you learn to do when you multiply those out is multiply your coefficients. So negative 4 times negative 2 is 8. And x times x is not 2x, but rather x squared. And then you do the same thing again. So negative 4x multiplied by negative 3. When you multiply the negative 4 and the negative 3, you get a positive 12. And there are no x's over here, so you just have one left. So the final solution to the product of that monomial times the binomial would be a positive 8x squared plus 12x. Same question. The only difference between this is now you have a monomial times a trinomial. Distributive property still has to be applied to all of the terms within the brackets. You would have 5x multiplied by a negative 2x squared. Multiply the coefficients to give you negative 10. And here we have x multiplied by x squared. And x squared, of course, is x times x. So x times x squared is simply, you keep the base and you add your exponents. So instead of saying x times x squared or x times x times x, you could say it, simplify it to be x cubed, which of course is different than if it was this, because x plus x would not be x cubed, it would be 3x, but that's not the question, that's just a side thought. Next one would be 5x multiplied by negative 2x. So multiply your coefficients to get negative 10. X times x is x squared. And finally, your last one is 5x multiplied by 1. Anything times 1 is itself, so we have a positive 5x. Now remember, at this stage, some people still think they can gather like terms, but in order to add or subtract those together, they need to have the same base and exponent, which they don't. So that is the simplified version that. Next question. It gets a little more complicated by using fractions, but the procedure of distributive property is still the same. So here we're going to actually take 1/5 x and multiply it by 5/8 x. Multiply your coefficients over here on the side. When you multiply your coefficients, well, obviously, a sane person would cross reduce. Instead of having 5/40, they would have 1/8. Multiply your x's to get 1/8 x squared. Now, alternatively, you could write it this way. I don't think anyone did, but if you did, that's great. But 1/8 x squared is fine. Multiply your next part with 1/5 x multiplied by -5. So what's 1/5 multiplied by 5? Cross reduce, you're going to get 1, or in this case, a -1. So a -1x is going to be your answer, or simply -x. You don't need to write a coefficient of 1. You now have binomial. You cannot subtract those two terms because they are not like terms. They have the same variable but not the same exponents. So your answer is simply 1/8 x squared minus x, or if you wrote it the other way, the fancy way, you have x squared divided by 8, or 1/8 of x squared minus x. Next question is a trinomial divided by a monomial. So the same procedure as if you were multiplying them applies for division. Each term in the trinomial must be divided by that. So you can write it separately. That's the first one. That will be the second one. And that will be the third term divided by -2x. Divide your coefficients. -2 divided by -2 is 1. X cubed divided by x is x squared. So you get 1x squared, or just x squared. -10 divided by -2 is a +5. X squared divided by x is simply an x. And finally, 8 divided by -2 is -4. X divided by x is 1. So I could actually put times 1 there, but I know that it doesn't affect it. So I'm just going to leave it as that, -4. And the solution to that trinomial divided by -2x. Okay, your next question, again, is a binomial, and then it's in brackets, divided by a monomial. Now, keep in mind that if I was to rewrite this, I could have written this with this division line. So instead of writing it the way I did, I could have written it this way, which still requires, if you think about it, both of the terms in the division to be, or in the numerator, to be divided by 1.2x. Or both of these terms here have to be divided by 1.2x. So if I rewrite them independently, my first part will be that. My second part will be this, and I just have to do them individually. So -4.8 divided by 1.2 is 4, or -4. Just to make sure with my calculator, 4.8 divided by 1.2 equals 4. A negative divided by positive is a negative. X squared will stay there. And the second one is -2.4 divided by the coefficient of 1.2 will be -2. X divided by x will cancel each other out. So when I simplify it, I end up with this binomial, -4x squared minus 2. No, not x squared. I forgot the x over here. Oopsie daisy. That's x. X squared is not going to be there. So the answer is -4x minus 2. Your next question. We have a triangle. And it says, what is the simplified expression that represents the area of this triangle? So, of course, area is base times height divided by 2. Or 10.4x minus 2, which is the base, multiplied by the height, which is 3x, divided by 2. So let's simplify the numerator first. If I have 3x multiplied by both of those, I'm going to have 31.2x squared minus 6x. So when I do the multiplication of the numerator, I multiply 3x multiplied by 10.4x minus 2. I end up with that expression. And then that, of course, will be divided by 2. So we have a binomial divided by 2, which will require distributive property. 31.2, if I take my calculator. No, that's not my calculator. 31.2 divided by 2 is 15.6. So your coefficient is going to be 15.6 x squared minus 3x. So your solution is the area of that triangle will be 15.6 x squared minus 3x. Next question says the length of a garden is 12x and its width is a quarter of its length. So I'm going to draw this and I'm going to put 12x as the length of the garden. And since its width is a quarter of that, its width will really be 12x divided by 4, which if I simplify that, will of course be 3x. What is a simplified expression for the garden's area and its perimeter? So since those are the side lengths, its area will be length multiplied by width, or 36x squared will be the area. And the perimeter will be the sum of all of those sides. So 12x plus 3x is 15x plus an additional 15x. Its perimeter will be 30x. Your next question is an addition pyramid. So the two polynomials or monomials or binomials below the one that you know will add up together to be this. So the first question you have to go is 2x plus what gave me a negative x? And the answer has to be, of course, a negative 3x. And a negative 2 plus what gave you a positive 4? Negative 2 and a positive 6 gave you the positive 4. So now I know that one. I'm going to add these two together. So a negative 5x squared plus 1. There's no more negative x squareds, or there's no more x squareds at all. So negative 5x squared will be there. That's gone. There's no more x's, so negative 3x will be gone. And the plus 6 and the plus 1 will add up to be a plus 7. So the one above that is going to be a trinomial. And then if we add those two together, this plus this, to get the one above it, I will get a negative 5x squared, because there's no more x squareds. A negative 3x and a negative x make a negative 4x. And a plus 7 and a plus 4 make a plus 11. Your next question is, what is the division equation for this particular picture? So if we think about it, that's like saying the area is negative 2x squared plus x, and the side length here is negative 2x plus 1. So what did I multiply negative 2x plus 1 by to get negative 2x squared plus x? And the answer is I multiplied it by a positive x. A positive x would complete that, so therefore the missing part of that model is a positive x. Your next question says, what's the multiplication equation for this? So we'll start with the monomial first. Negative 2x multiplied by 2x plus 1. If I use distributive property to figure it out, I'll have negative 4x squared minus 2x. And if I was actually to fill it in here, that's what I would end up with, negative 4x squared minus 2x. What is the addition equation for this? Well, here I have a negative 2x squared plus x plus 1, which is a trinomial, plus a positive x squared, a minus x, and a plus 1. So it's a trinomial plus a trinomial, and it's looking for the equation, which means I also have to solve it, or gather like terms. When the x squareds are combined, I get a negative x squared. Pictorially, that's what it would look like there, leaving with a negative x squared. Positive x and the negative x will combine to make a zero pair, so there's no more x terms. And the plus 1 and the plus 1 will combine to make plus 2. So therefore your equation, if I go back in time, is negative x squared, negative 1x squared, not 2x squared. Negative x squared plus 2. There's your equation. So that whole thing would be the equation that you needed to write. And what's the subtraction equation for this model? Again, same thing. So it's 2x squared plus x plus 1 in brackets. Take away a negative x squared minus x plus 1. Just like integer operations, if you're going to subtract a polynomial, you have to change it to addition and use the opposite of every term within the trinomial. Now that you're adding polynomials together, gather like terms. 3x squared plus 2x, and remember these two here are going to combine to make a zero pair. So your solution would be 3x squared plus 2x. I think that's the last one. That was the last one.